Here we're being asked to calculate the double integral over this lovely region D, D is this diamond here, of x plus 1 with respect to area. So I've got to figure out how I want to set up my integral. And here, if I were to slice things vertically, I can certainly do that, but I can see I'd actually have to break this up into two regions, because to the left of the y-axis, the bottom function is this line, but the bottom function changes to being this line to the right of the axis. And to the left of the x-axis, of the y-axis, the top function is this line, but it changes. Now, I could describe each of those using an absolute value, but that doesn't really help, because the way you integrate an absolute value function is by writing it piecewise. So I really have to deal with those two parts separately. So I don't have a consistent bottom function or a consistent top function, so I'm not crazy about that. But if I try doing it the other way, I see I've got the same problem. If I try to slice things this way, the left function changes and the right function changes. So either way, I'm going to have to split this into two pieces. Okay. I'm actually going to choose to do it this way. Okay. Might seem I've got to do two pieces either way, so why don't we go with this, because we're more used to having y as a function of x than x as a function of y. But I'm thinking if I do things this way, then I might be able to take advantage of some symmetry. Because if I break this up into two pieces, essentially the top part and the bottom part, each of those pieces is symmetric about the y-axis, and we'll see if that helps. Okay. So I'm going to try to do it this way. I'm going to set it up as a sum of two integrals. So I'm basically going to have that bottom part, which I'll call D1, and that top part, which I'll call D2. Okay. So I'm going to say this is the double integral over D1 of x plus 1 dA, plus the double integral over D2 of x plus 1 dA. Should make some sense. These two regions are non-overlapping, and together they make up the region D. I'm actually using a property that we're going to formally state in the next video, but makes some sense. I'm working over this whole region, but I just broke it up into two parts. Okay, so if we're working with D1, let me just draw that here. So we said this point was negative 1, 1, and this point was 1, 1, and we were going to slice things this way. Okay, so this I can see is just a line of slope negative 1. And it goes through the origin, so it's just y equals negative x. This is a line of slope 1 through the origin, so that's y equals x. So integrating along each slice, I'm going from, but I have to remember, if I'm going from left to right, I need to solve this for the x values. So here, that's solved for x. Here, I want to say x is the opposite of y. So I would be going from the opposite of y to y, x plus 1, that's integrating with respect to x, and then the thickness of the slice is a small change in y, and the slices start at a height of 0 and end at a height of 1. Plus, now we've got to do D2. So that's the top part. This point is still negative 1, 1, and this point is still 1, 1. This point is now 0, 2. Slicing things this way again. This is a line of slope 1. Y-intercept is 2, so this is y equals x plus 2. Looks like this is a line of slope negative 1 with a y-intercept of 2, so y is negative x plus 2. If I'm going from left to right, I'm describing the x values, so I would want to solve for x in terms of y. So I could say x is y minus 2, and here I would say x is 2 minus y. So we'd be going from y minus 2 to 2 minus y, x plus 1 dx. And then our y values now are going from 1 to 2. Okay, So I've set up my limits of integration. Now I wanted to do that because we did have to break it up into two regions. It turns out now I'm going to do a couple of things that are going to make it actually not necessary that I did this, but that's okay. All right, so both of these regions, D1 and D2, are symmetric about the y-axis. So if I have a point here that I call xy, its mirror image point would just be the opposite x value, but exactly the same y value. Okay, and that's going to be true if my point xy is in D2. The mirror image point has the opposite x, but the same y value. Now, if I look at the heights, I'm not going to get exactly the same thing or exactly the opposite thing on either D1 or D2, because that 1 is always going to be a 1. But here's what I'm going to try to do. Integral 0 to 1, integral negative y to y of x dx dy, plus the integral from 0 to 1, integral from negative y to y of 1 dx dy. So what I'm trying to do is split up that integrand into two pieces. Can I do that? Yeah, because we're just integrating twice. I know for a single integral, if my integrand is a sum or a difference of pieces, I can integrate each term separately and then add or subtract the results. So I could do that on the inside, and then I could do that for the outside integral. Now, that's going to help me out, because now the height that I'm attaching to things here is x, and I'm getting opposite x values, so opposite heights here. So this will be 0 by symmetry. Here, I'm integrating 1. This is going to be the area of D1. But D1 was a triangle, so that's going to be 1/2. Looks like I've got a base of this horizontal distance would be 2, and the height here would be this vertical distance of 1, so that's just going to be 1. And then I'm going to do the same thing here. Integral from 1 to 2, integral from y minus 2 to 2 minus y of x dx dy, plus integral from 1 to 2, integral from y minus 2 to 2 minus y of 1 dx dy. Now here, if I'm in D2, I have that same symmetry. The point here and the point here have opposite x values. The left side is a mirror image of the right side. We get opposite heights. So I can say this is 0 by symmetry. And now this is the area of D2, which is also going to be just 1, because that's another triangle whose base is 2 and whose height is 1. So what we ended up with, we had 4 integrals, but we didn't do any of them by integrating. We did all of them by inspection and geometry. So we end up with 0 plus 1 plus 0 plus 1. We end up with 2. Now, that's not the only way to do this. You could certainly have set things up and done the iterated integral. That should lead to the same thing. I just wanted to point this out. And this used a couple of properties of integrals that seem reasonable because we talked about why they work. In the next video, I'm going to formally state a number of properties of integrals, because it's important that we don't just assume things. So anytime I used a property, I said, here's why we can do that. But it's good to just state, here are all the things that we are allowed to do with our integrals.